And it's my great privilege to introduce Joe Hughes, Professor Joe Hughes, who is a distinguished professor of engineering at Drexel University. I've known Joe for years now, when he was at Rice University, when he was at Georgia Tech, and where he was professor of environmental engineering, chair of civil and environmental engineering, dean as well at Rice University in his latest position. Joe, to give you an idea, endorsed peace engineering as early as 2014. I remember going to Drexel, and he put together an interesting group of about 20 faculty members on campus at Drexel, all interested in peace engineering. At that time, the elephant was really big. I had no clue what it was about. But Joe had that vision that, yeah, into peace engineering. Almost fell off my chair when he talked about it. And I really fell off my chair when he talked about we need to create a department of peace engineering on campus as well. You can do it. You're the dean. You're the big boss here. And he did it. The department, I don't think the department is kind of part of another department right now. Lots of awards that Joe got in his work. I admire his vision, I admire his friendship, and I'm privileged to know him as a friend, as a colleague. And today I think it's good to share with us the vision that he has for peace engineering in engineering practice as well as in engineering education. Joe?
Bernard, can you hear me?
Yeah.
Okay, good. Thank you for that introduction. And thank you to all my friends at University of New Mexico for the opportunity to be at this conference today. I wish I was there in person, but maybe in future years, that'll be easier for all of us to do. When I was asked to talk today, Ramiro suggested that I try to give a broad perspective on peace engineering just to get things going. And so I have a few slides I'd like to work from today. Let me see if my sharing of screen will be seamless here. So today I'd like to talk about the field of peace engineering with the hope of beginning today's discussions about the opportunities of peace engineering as it relates to some of the current global crises, such as climate change and obviously the pandemic that we're living in. When I'll be talking about peace engineering, for many people, they haven't heard the term peace engineering before, or if they have, they've seen it in sort of an emerging context. And I thought to start our discussion today, it'd be important to say that the idea of peace and the involvement of engineering in global challenges is certainly not new. Neither field is new. What is new is how we think about the combination of the two and the idea of a dedicated, concerted effort at the combination of peace and engineering to be an additive solution domain to the challenges that include climate change and things such as COVID. So to begin with, it's really important to always say that what we're working on here is not really new. I will tell you what I think is new about what we're doing in just a minute. But as Mark Twain said a long time ago, there's really no such thing as a new idea. In fact, engineers have been involved in issues related to peace for quite a while. Now, typically that has been through issues of peace through strength, not typically the types of conversations we have about peace engineering, or the involvement of engineers in the improvement of quality of life, which oftentimes results in a more peaceful society. But in either case, the idea of peace through strength or the idea of peace as it relates to quality of life has been somewhat indirect involvement of engineers, at least indirect in the problems or the problem statement of a more peaceful world. And certainly a more peaceful world in the light of today's challenges, such as mass migration from climate change. So when we talk about peace, we're talking about the engineering that relates to peace. It's not entirely new. And it's important to recognize that as we get started, because many people, after they learn more about this emerging field, they say, wow, so I've sort of been a peace engineer for a while. And my answer to that is, yes, you probably have been for a little while. You just haven't had a chance to make it your moniker. So beginning with thoughts about peace. Peace is an old problem. It goes back to the dawn of time. And I use this as an example of some of our recent work on peace engineering that was published in the Bridge from the National Academies, as a place to where we talk a little bit about peace as an old problem. But peace as an old problem means it's a hard problem. We haven't solved it yet, engineers or anybody else. And I think one of the biggest challenges when we talk about peace is that it's a wicked problem. So by a wicked problem, it means the solution changes with time. There is no deterministic solution to wicked problems. And engineers historically have been pretty good at deterministic problems, and we're getting better at working on wicked problems. But peace is clearly a wicked problem, and on a scale that's probably bigger than we've worked on, most engineers have worked on in history. The other challenge with peace, and it might be something that comes up today, is there's no uniformly defined definition of peace. In fact, if we polled people in the room and asked them what is peace to them, we'd probably get a wide range of different answers. Peace is not a shared definition for most people, for anybody. And so we have a wicked problem, and sometimes communication on that problem is tough because people see the endpoint as being something different than perhaps the person just sitting right next to them. So when we think about peace as an old problem, and engineers, as Ramiro said, as problem solvers, we ask the question, well, why hasn't this been tackled so far by engineering disciplines? And I have on this slide the classic engineering design process. This is sort of what engineers tend to use to work on solving problems. And it begins with a question. You ask a question, and from that question, you start to work on a solution. Now, different people with different definitions of peace will ask different questions. So I gave 3 of them here. The problem is there's not enough peace in the world. Or maybe you say there's not peace in my community. Or for some of us, it's there's not enough peace in me. So this is across 3 different scales. Regardless of which one of these problems we're trying to insert as a question into the engineering design process, historically, our process sort of falls apart. It doesn't yield an outcome to the solution of these types of problems. We don't get very far historically, we don't get very far into our design process before we just simply don't have the tools to be able to make much progress. And eventually, we just say that the problem is bigger than what we're able to work on, and there exits the engineer from being part of or an additive part of the solutions. But I would contend that this is changing, and it's changing in ways that are very empowering and timely for the types of challenges that we're talking about today. So there's a range of tools that have been coming from other fields, some technology fields, many of them from social sciences, that contribute now to our ability to address complex systems like peace being a wicked problem, a complex system. We think about peace or violence or conflict, we think about emergent processes. We think, but as we go to other disciplines and look at the tools that have been developed over the recent decade, maybe 2, we see things like game theory, collective behavior, network science, nonlinear dynamics, systems theory, pattern formation, and the field of evolution and adaptation, which goes across more than just biology, goes into a wide range of different disciplines. And we see an enormous capability or enormous toolbox that I believe will help feed into that engineering design cycle and actually allow us to begin tackling or addressing some of the problems related to peace at its various scales. I don't want to go into the details of any of these. This is obviously a huge collection of different areas where sciences, social sciences, deterministic sciences are contributing to the toolbox that engineers can use in peace. But what the idea here is that old problems get solved by new methodologies and with new tools. And those new tools are coming together very rapidly and significantly towards issues that we can actually begin to work with in peace engineering. One of the main questions I get when talking about peace engineering is, well, how do you do it? How do you tackle tough problems, big problems like this? It's also good to recognize that we've changed our methodologies in engineering over the past decade or 2 to be able to tackle more complex problems. And I don't want, again, I'm going to go into the absolute details of these methodologies, but a great example of methodologies to address complex systems problems is the Scrum methodology, where we where we create diverse sets of questions, bring together diverse groups of people to work on them in parallel, and work them through a methodology that quite efficiently yields technological products that otherwise we haven't been able to create in the past. Those of you who have background in software engineering, know the Scrum methodology very well. But Scrum methodologies and Agile frameworks such as these, in terms of product development, work very, very well in peace engineering. And it gives us a framework for how to work on these complex problems. So old problems, new tools, and adapted methodologies that allow engineers to begin to tackle or work on issues related to peace. I would use as an example of how peace engineering could work for us as a society, with safety as an analog, or an analogy, maybe is a better way of saying it. So it used to be that we just said accidents happen. I mean, what are you going to do about accidents? They just happen. And then there was a group of people who said, well, they shouldn't happen. At least they shouldn't happen as much as they do. And safety was an example of a wicked problem that was addressed by engineers over a period of decades and decades. It's resulted in tremendous success. I use one example here, which just shows vehicle miles versus annual deaths. This is in the United States. So this is automotive deaths versus vehicle miles driven. And we see deaths drop dramatically while miles are growing up significantly, as an example of what engineering towards safety does when worked as a systems problem. Interestingly, people thought this was impossible because people were unpredictable, but in fact, people become somewhat predictable, and we've not gotten deaths obviously to zero, but we've certainly reduced the amount of fatalities as a result of automobile deaths by safety engineering. And in some ways, I think of peace engineering in a similar manner. In other words, there's not a single solution, and there's not going to be a solution that creates peace to the snap of a finger. But there's opportunities through incremental and compounding engineering outcomes to, as in this case, reduce fatalities in a complex system such as transportation. I think in peace, and I think it's true in any of those scales. Now, we've yet to do the work, and maybe someday we'll see a plot that looks a lot like this with regard to whether it's fatalities or dollars spent on violence or any number of metrics that we might think of in terms of peace. We've yet to create this chart, but I think this is where the emerging peace engineering field is headed, much like safety engineering, developing solutions that are incremental, compounding, and working within wicked systems problems, ultimately to achieve results with this kind of as an analogy. So Ramiro brought up the NEA Strategic Plan, which was recently released. And I think that it's a good place for us or a good place for me to sort of wrap my discussion today as we look towards the future of systems engineering and see where it is related to what others in the engineering fields see as being important. So there are 4 key elements of the NEA Strategic Plan that I show on the slide. These are the only 4 that are in the plan, by the way. One is to increase engineering talent with a commitment to diversity, equity, and inclusion. Second, to instill a culture of ethical and environmental responsibility in engineering. Third, identify and inform frontiers of engineering theory, practice, and policy. And fourth, improve capabilities in systems engineering. In my opinion, and I may be slightly biased, but in my opinion, there's few areas in engineering, old or new, that more directly speak to these stated strategic goals of the National Academy. We have limited information, but interesting information with regard to the interest in peace engineering from diverse student bodies, more so than probably any engineering discipline, maybe with the exception of biomedical engineering or environmental engineering to date. When we think about peace engineering, we're thinking about ethical and environmental responsibility in everything that we do. It's sort of baked in from the beginning of peace engineering. It's not something that's an add-on to an old engineering discipline. Certainly, the idea here is to inform, frontiers and policy at all levels, and using both theory and practice. And last but not least, what I've been talking about today are the opportunities to actually build complexity of systems engineering into the solution of complex, wicked societal problems. In this case, peace. So our alignment with the engineering discipline, the engineering field is extremely tight. And the idea that we're working on what others see as being the important fields, emerging fields in engineering, I think is clear from the NEA Strategic Plan. I think offers a lot of opportunity for us today to talk about how we develop peace engineering with the support of the engineering community as seen through the strategic goals of National Academy. So with that, I hope I've opened the floor for discussion today, Ramiro, and hopefully there's time for a couple questions. My email address is here for anybody who would like to reach out to me if you have questions. I know I went through things very quickly, but hopefully enough to at least get the conversation started. Again, thank you for having me today.
Thank you, Joe. We have a question here.
Yes, so I've seen on the previous slide that you actually have a degree in peace engineering.
At Drexel, we do have a degree, a master's degree in peace engineering. I'm not a recipient of one of those degrees. So I hope there's no confusion there.
Not you as a person.
Okay, yeah, Drexel has a master's degree in peace engineering. We're working right now, I am working with Ramiro in the development of a proposal for a PhD program in peace engineering. We know that obviously New Mexico has a minor in peace engineering. So ideally between what we're working on at Drexel and New Mexico, we're actually looking at a continuum. But yes, we have a degree in peace engineering. We have graduates in peace engineering. And I believe some of our students are actually here this morning to learn from this audience.
Yeah, so how many students you have in that program?
Oh gosh, I wish I had the list. I think right now we're between 10 and 20. I don't have a number on it. Where this gets complicated for us is that we have a BS MS program at Drexel where we sort of do accounting a little bit differently. We have a number of students who are doing a bachelor's degree in some engineering field with a master's in peace engineering. Then we have students who enroll in peace engineering as their sole master's degree, kind of in the more traditional framework. And again, the traditional framework, we're between 10 and 15 right now. In the BS-MS program, it's very hard to count because some of those students are in their pre-junior, junior, senior years. If we included all of those, maybe closer to 35 or 40. I could get those numbers firmed up for you by the end of the day, I bet.
Thank you. Thank you, Joe. Camille, you have raise your hand. You have a question?
I do. Joe, good morning. Good to see you.
Good to see you, Camille.
It's not really a softball question, so apologies. Everything turns out to be focus, right? You have 32 items that were on the toolbox that says, here's how we can do it. How do we mobilize the efforts to be able to make progress enough so that organizations, for example, like Sandia or Sensorcom, can now turn around and say, hey, we're working in peace engineering, and that's not taboo. Like, that's a viable strategy, as opposed to the, hey, are you really a kook? What is this peace engineering? You're living in San Francisco, you're hugging trees, now you're working in peace engineering. I've had that discussion with the board of directors. They're not happy about peace engineering yet.
It takes a while for people to get their arms around really complicated problems. And I'm no different. It takes me a while to get my arms around things too. Peace is a complicated subject matter. And there's really kind of two sides to the discussion, and one is a little easier for people to digest than the other. So for some, peace is the absence of violence. And so if we think about ways to reduce violence, I'll give you an example. I work for the state of Pennsylvania, the governor's office, not for the state. I work for the governor's office on the reduction of gun violence in Pennsylvania. So that's an issue of violence right there. And I say, well, peace engineering, we're trying to understand gun violence and reduce the incidences of gun violence. And most people say, oh, okay, I get that. Okay, that's within my definition of peace, and it's a complicated societal problem, and I can talk about the systems approaches we're using for that. The other side of peace that is more complicated, and I think maybe, I don't know if it's more significant, but it's equally as significant, if not more, is the idea of creating resilient institutions and more equitable institutions. And right now, we're living in a world that's just overwhelmed with cognitive violence. And the idea that what that does to institutions is we can't even measure it today, but there certainly are the opportunity for governments to fall as a result. The idea of working on some of those issues as it relates to institutions and building more strengthened institutions and institutions that can solve and deal with the problems, such as example as climate change, is something that's more abstract and harder for people to get their arms around. Where most people do agree when they start to think about peace engineering is we think about the amount of money, the cost of conflict and violence in the world, which is over $14 trillion a year. They think about the personal costs that most people in some way have felt as a result of things that relate to violence and conflict. And usually it's from that negative perspective that people enter. Getting to the more positive components of peace engineering has been my challenge, and one that ideally will become an easier sell in the future.
So I thank you.
Thank
That's
you.
a great answer, Joe. And we have a number of additional questions. So what we asked you to do is to put them either on the survey or in the chat, because we have a really full agenda.